Hello. In this video, we are going to start talking about the double angle trig identities. Just going to say trig from now on. There's no need to say trigonometry. It lends greater prestige to the concepts of trigonometry than perhaps they deserve. Identities. So the double angle identities are about finding what the trigonometric functions of 2 times some angle is. And that's a weird question to ask, right? So let's say we're looking for sine of 2x. What does it mean by what is that equal to, right? If we're trying to find out sine of 2x is equal to something, we have to really think about the context. So the sine of 2x is just equal to the sine of 2x, but let's say we just know the sine of x, or the cosine of x, or if you know one, you know the other. And we want to find the sine or cosine or tangent of twice that angle. So now we have some context. So what we need to do is put sine of 2x in terms of some values that we might already know about x, some common values. So what's an example of that? Well, this looks a little bit like the angle addition formulas, right? And those are in terms of sine and cosine. So this can also be written as the sine of x plus x. And of course, when I mean that they're written in terms of sine and cosine, I'm referring to the sine and cosine angle addition formulas, which are really the only ones that you tend to use, because you can just find the tangent of any given angle by finding the quotient between the sine and cosine. Well, let's get back to this. So the sine of 2x is equal to the sine of x plus x, right? So let's pull up our angle addition formula. That's going to be, I'm going to write it at the bottom of the page. We know that the sine of alpha plus beta is going to be equal to sine of alpha times the cosine of beta plus the sine of beta times the cosine of alpha. Simple enough. So what happens when we make alpha and beta the same when we're adding x to x, or we have 2 times some angle? Well, let's go back to our problem. This is going to be equal to, let's just plug it in, right? The sine of x times the cosine of x, because we're treating x as if it's 2 different angles here that we're adding, when really it's just one angle that we're adding to itself. Now we're adding the sine of x times the cosine of x. And look, these expressions here are identical, so we can just combine them, and that's going to be 2 sine of x cosine of x. And we're going to be getting into some examples as well as deriving all of the other formulas. As you'll see, we get a little bit more complicated when we get into cosine, but that's also where the most important identities come from. In my opinion, the double angle cosine formula, it says a lot more about angles and power reducing, which we'll get into, which will be useful in calculus and mathematics from here on. Thanks for watching.